And now, as I say, something completely different. I'll be talking about building appliances with Android. Now, you might be wondering what that means. It's basically turning something into the equivalent of a toaster, or basically building an appliance app. Now, what I mean by an appliance is basically what the dictionary definition says. It's like a device that's designed to perform one specific task. It's not a general purpose device. Now, there's things that in everyday life that we're pretty familiar with that are appliances. It's a microwave oven. But in this particular context, what I'd like to talk about is what I've been working on for roughly the last year, which is interactive digital signage devices, which is a huge mouthful. And basically it means things like that. That's actually not ours. Those images I got off the web before we had publicly available images of our applications, especially that Nokia one that's really up to date. But that gives you an idea of what they are. It's the kind of things you see in the shopping centres or down at the local bank or something, things that like you poke at and they hopefully tell you what you're after. Now, in order to create an appliance with Android, you need to customize it. Android is a general purpose operating system designed for consumer devices, phones and these days tablets, or even moving into TVs. Now, you've basically got 3 levels of customization available to you with Android that you can work at. The first one is user, or user level. And what I mean by that is basically things that are available to you yourself as an Android developer or as an Android user of a device. Can I just get a rough idea of how many people are Android developers? So just like, no, okay, about half. It's just, I've got some slides coming up, so I want to know whether I go through them quickly or a bit more slowly. Now, the second level is the platform level. Now, this can be thought of as kind of the root or admin level, depending if you're from a Unixy or a Windowsy background, because basically Android's security model involves protecting sensitive APIs from applications like, as that Android developers probably know, in Android all apps or applications are considered equal, but as an Animal Farm, some are more equal than others. And the ones that are more equal than others are the ones that have permission to use the sensitive APIs on your device. Sensitive APIs are things like changing particular settings on your device, being able to do things like reboot the device. And I'll come to that in a bit more detail later on about some of the APIs that fall into this category. Now, the way you get access to these APIs, if you need to use them, for instance, like the system settings app on your Android device, is that the vendor who built the system image for that device gets to install a certificate on the device that is used to determine whether an app has permission to use these sensitive APIs or not. The typical app that comes from Google Play Store that you sideload yourself is signed with your own certificate or one that someone else created, and it's not the same certificate that's called the system certificate that was placed on the device when the system image was created. And that's what determines access to these APIs. So the vendor or the manufacturer who makes your device signs their system settings apps and other apps that need access to these APIs with that system key. Now, The main thing to remember also is that Android, being a consumer operating system, is also, or mobile consumer operating system, is following along the lines of iOS and trailing behind with, and others that are following behind, like Windows Phone, which is that users are not expected to ever actually have admin or root access to their devices. You might have the device, you might own the device, but you are not expected to be in control of the device. For good or for bad, that's how it is. Like, people who work in a corporate IT environment probably are very used to this. Like, your company issued laptop normally doesn't give you admin rights to it, whether it's a PC or a Mac. Normally that's something that's locked down. And for better or for worse, this is the way that things are going in the mobile operating space, that the devices are not being shipped to end users with the ability to control the system level parts of the operating system. Now, the third level is the operating system level, and this is where you're in fact rebuilding essentially the whole operating system. Any old school Linux users here? One or two? This is, for anyone who used Linux in the dark past, where you had to rebuild most of the operating system from scratch, this is what the level I'm talking about. So let's start with the first level, user level. What are the kind of things you can do at this level? Well, you can do things like register your app for the home intent. I don't know if everyone realizes, but the home screen on your phone or tablet isn't just an app like any other app. It's simply registered for a particular intent, in this case the well-known home intent. And so when you press the home key, the system generates the home intent, and any apps that are registered for it are given the opportunity to receive it. If there's more than one, of course, the user is actually prompted with a list of all the available applications that can handle it, and the user gets to choose. The user might want to select one as the default, and that's the one that stays. And so there's quite a cottage industry in Google Play Store of launcher replacements. So you might have been using some, you might have tried one or two out. So that's how they work, is they take control of that intent. They basically respond to it. Now, just quickly cover for those of you who aren't Android developers what intents are, because I'm going to be talking about them a fair bit. It's basically a messaging system within Android that Android uses to send messages and to transfer control between applications, because actually applications in Android are really bundles of things, and the things that you see on your screen are called activities, and intents usually cause an activity to be shown to a user. I'm simplifying it a lot for the non-Android developers, but it's basically a way of sending messages and transferring control between applications. And you can have either direct intents, which are sent to a particular, well, they can be sent to a particular activity, or they can be sent with a particular, they're unicast but with a particular name, or there's just broadcast ones, which any app that's registered to receive those broadcast intents can be informed of. So that's basically what the default home looks like. But of course, as I said, you write your own app that just registers for that intent, and that's something that's what you can do, and that's supported through apps from the Google Play Store. But what you can also do is, once you've registered your app to receive the home intent, your app can also respond to back events. So what you can do is register for the home intent. Say if you ask the user to choose your app as the default, then every time they press the home button, your app shows up. But what if you also handle the back button, which is just a standard API, and say decide to do nothing? Then when the user presses the back button, they can't get out of your app either. So that's a reasonable way of starting to lock down a device to only run your app. So think of the use case of having a web kiosk, for instance. You want to have your app present a web view, and if the user presses home, they just stay in your app. They press back, they stay in your app. But they still can get out of your app, because in newer ICS and later versions, they can press that little key that shows you previous apps and activities that you've had up. And of course, they can also power cycle the device and get out, reboot the device and get out of your app that way. Though interestingly, if your app is the default home, they'll still reboot back into your app. So you're most of the way there just by working at this level. But with especially newer versions of Android which don't use hardware keys, you can't completely lock down the interface just doing this. Now I'll just quickly show you, for those who don't know, that's all it takes to register your app for receiving the home intent. Now you can also register for use other intents which are treated as public APIs by Google with Android. So they're kind of well-known names. So intents have an action, a namespace name, which represent what they're doing basically. So for instance, there's well-known ones which, for instance, will bring up the Wi-Fi configuration from within settings. So you can use that if your app needs to prompt the user to select a Wi-Fi network to go onto. If your app detects that there's no network connectivity, you can just, from within your app, fire off the Wi-Fi intent and it'll show the Wi-Fi configuration screen. So sending intents, that's as easy as it gets in Android. And that's all you really need to do that within your app. You just basically create a new intent object, fire it off, and up comes your Wi-Fi configuration. So you detect that the user needs to set up the internet to use your app, fire that off. Now, one thing though is I'm talking about Android appliances. So these are the kind of things, like I said, that you want to lock down because they're a single purpose. You don't want people to go just trying out the calculator or just trying to send emails with any of the applications that are installed on there. And the problem is if you try and lock down the device, so for instance, you have a way, which I'll talk to you about in a minute, of not letting them navigate away from your app. The problem is if you show them this, that's cool. They can select the Wi-Fi network they want to connect to, but then how do they get back to your app? How does your app know that they've finished this? And the people, or the developers at Google, had exactly this problem, because if any of you have gone through the configuration wizard when you first get a reasonably new Android device, you might have been asked, like before you got to register your Google account, you might have been prompted to connect to the internet, and you would have seen the standard, say, Wi-Fi configuration dialog like I showed you there, but Google engineers had the same problem. They needed you to go back to their configuration wizard. So I think in these situations, they must have done what I do and asked themselves, what would Kirk do? And the obvious answer is, you change the rules of the game. If you're a Google engineer, you get to change how things work in Android. So what you find, if you open up Android source code, the platform source code, you can just go and download it. It's huge, but you can just grab it and have a look through the huge amounts of source code there and track down where the Wi-Fi configuration activity code is. You will find some undocumented, completely undocumented extra data elements that get passed along with an intent. So I should have mentioned before that intents can have basically parameters. So it's like a function call, and these these are called extras. And so with the intent that triggers the Wi-Fi activity, you find in the source code there's a whole bunch of these extras that are not mentioned anywhere in the SDK documentation or anywhere else, unless you look at particular forums on the web. And you might be able to tell, if you can read it, I'm sorry about the colouring. There's one's called Only Access Points, Extra Prefs Show Button Bar, Wi-Fi Enable Next on Connect, Extra Prefs Set Next Text. And you can probably guess what they do. Yep. You pass in those magical undocumented extras, and what you get is the nice little button bar on the bottom with back and finish, and you can actually even set that text. I just set it to finish. You can set it to whatever you want, or localize it. And voila, problem solved. Your user can now select the Wi-Fi network and get back to your app. So, next up is the platform level. Things you can do at this level, you get to call the privileged APIs that I've talked about before. So you can do things like reboot the device if you want to. You can also do things like silent OTA updates, which I'll talk about more in a sec. So once you have this level, you can do these kind of things which no normal application can do. These are APIs that are supposed to be restricted to the system apps that are shipped by the vendor with the device. Now, what do I mean by silent? Well, normally, if you install an app through Market, it gives you a little prompt saying, yes, are you sure? If it's paid, do you want to pay for it? If you sideload an app, you'll get the same kind of prompt. And in fact, there's actually a public API that any app can use to install another app or another bundle of code called an APK in Android. There's a public API. It's, again, another intent that you just send, and hey presto, the system will install it for you. But what it'll do first is it'll prompt the user with a little dialogue saying, would you like to install this app, or something along those lines. I can't get the exact text. But if you're building an appliance, especially a signage appliance that people are walking past every day, you don't want these dialogues to pop up when you, say, have to push out a critical update because you found some bug in your app, and have this dialogue sitting there on the screen, which you've all probably seen, those kind of little fail whale things, or whether it's gone to the Windows desktop, or like I've got a nice screenshot of an Ubuntu desktop in the Mac's that came up because something went wrong with the system. You don't want those kind of things to show up in your signage to tell people, hey, something's gone wrong, or hey, I'm trying to do an update. So if you've got access to this privileged API, what you can do is a silent update. You can just basically call this API and say, hey, I want to install this new version of the APK, and it will just happen in the background, no user interface interaction whatsoever. Which is, of course, something you don't want for regular apps, but that's actually how Google Play Store works. The prompts it shows you aren't actually part of the system, they're part of the Google Play app. But in the background, it gets to call these privileged APIs. So onto the third level, which is now we're going down and down, and now we're into the really dark depths of OS level customization. And in fact, I lied. There are actually 4 parts. So there's the operating system when it comes to the Android framework, and then below that is the kernel. And for those of you who know, the kernel is just a Linux kernel, mostly standard. But the Android framework is very different from normal Linux distributions that you may have, or Linux systems that you may have used in the past. It's pretty much done from scratch. So it's best to treat it separately rather than talking about it and the kernel together. Now, how do you customize the Android, oh gosh, spelling mistake, framework customization? Well, what you can do is basically rebuild the operating system from scratch. Now, it's all available online, it's published, it's open source, but there are things to be aware of. You're essentially rebuilding a whole operating system from scratch. It happens to be Android, but it's the equivalent of Mac OS X, iOS, Windows. So we're talking hundreds of Git repos, that's Git source code repositories, and I do mean hundreds, I think 230 odd or something. I get the exact count. So you need huge amounts of disk space, and to actually run the whole build, we're talking at least 1 hour, at least from a cold start, on an i7 quad-core type machine. So it's not something for the faint of heart, and it's a little bit laborious, but otherwise there's good documentation on Google's website. Like, for all the criticism that Google gets about just every 6 months or so, just dumping their code on the world, it is all under an open source license and freely available, and lots of people do just grab that code and build their own custom versions. And they don't even all do it like me for paid work. Some people just do it for the fun of it. So, and then once you've actually built, I should mention, once you've actually built your image successfully, you need to test on something. The simplest way to do it is just to use the emulator that comes with the Android open source project. but you probably want to build for a specific device, specific piece of hardware, and test on that. So that becomes a bit laborious because there's a lot of copying backwards and forwards in that case. Now, when you come down to the lowest levels of the operating system, the kernel, things you can do here are, oh sorry, actually, sorry, gone a bit too far. What you can also, what I should also cover is things that it gives you when you get to customize the Android framework. The practical aspects of what you get out of it are things like what I spoke about before. You can remove the system bar. So for those of you who use Android 4 onwards, hardware keys are no longer compulsory, so you can often just have software home back keys on the screen without any hardware keys whatsoever, and that's what's called the system bar, because it integrates the navigation and the nav and the nav bar together. Now, as I said before, if you're doing something like a signage screen, you don't want that on your screen showing up. You want your content to be full screen on the device. So what you can do is, in customizing the Android framework layer, you can remove that altogether. Other things you can do is you can choose not to use an ARM device. So for instance, there's a community-led project to run Android on x86 devices. So you can run it on a laptop. We run them on various devices, from quite small machines, which just have an Celeron, all the way through to machines with i5 processors. Just runs, works fairly well, and you just need to be able to compile the source from scratch, because, well, you also need to do any configuration you require for your devices, such as drivers, and luckily the community project called Android x86, the people there have done a lot of work porting Android across to work with typical Intel graphics cards that you'll find in these kind of laptops or small desktops, things like that. Not so much support for the fancy NVIDIA graphics cards, but luckily we don't need that. You can also do things like add workarounds for buggy hardware. So one of the things I had to do recently was cope with an LCD screen that would report its resolutions out of order. And I found in the Android code, it was just expecting the highest resolution to be first in the list of resolutions reported. So I just needed to add a small workaround there to actually re-sort that list to ensure that the highest resolution was coming up first in the list and was being the one that was automatically picked up by the system. Now, the other thing you can do, coming back to what I spoke about before, is you can use your own certificates. So you get to decide now which apps have permission to call those sensitive APIs. It's no longer Samsung or LG or whoever your vendor is, or Google even, who's distributing your device, choosing to put their certificate on there and deciding which apps get to access the system. You can put your certificate on there, and without what's called rooting your device, what you're doing here is you're not introducing a security hole, you're actually controlling which apps now get to control the sensitive parts of the operating system. Now, finally, I'll just, because I'm running a bit low on time, I'll come to the lowest level, which is the kernel. And this is basically recompiling the Linux kernel from scratch. Now, what this lets you do is basically any customization you need on that level. So it really comes down to things like hardware drivers. So, for instance, we needed to support several non-HID compliant touchscreens. So we need to be able to compile those drivers as kernel modules or within the kernel and ship that on the devices that we were using. So in order to do that, this is, you have to work at this layer. There's no getting around that. With Linux, there's no easy way for what's called user level app code to get access to raw hardware on the device. So if you want to talk to a USB device that's non-standard, so for instance doesn't use the standard HID human interface something definition profile, you need to have your own drivers, and they need to be kernel drivers. So that's typically the kind of thing you need to do when you're working at this level. And I think that's about it. I had hoped to show demos, but I think I've used up most of it. No, we're right? Okay. So hopefully I can just bring my mouse across to our level. One thing I can show is basically what I was talking about before about removing the system nav bar. It's not particularly impressive, but I'll move that into here. So that's just, of course, I'm just not running on a real device. I'm just going to run it here in an emulator. Oh, one other thing I should mention is that sometimes you need to work at different levels. So for instance, one thing that I just got as a set of patches off the Android x86 community was Ethernet support, which at least in ICS doesn't come by default from Google. And for that, what you actually need to do is work at both the kernel layer to make sure that you're supporting the right, you've got the right device drivers for whatever network cards you need to use, as well as adding support in Android framework to be able to let your applications talk to the Ethernet card that you need to use in the same way they would use Wi-Fi or 3G cellular data. So I'll just pop in there. I just need to basically bring up, in order to be able to talk to it, because this is, I'm not using the standard emulator that comes with the SDK, if people are wondering. This is just the kind of generic version of that emulator, which I'm using to run my own images. But one thing I need to do is to turn Ethernet on to be able to use ADB over Ethernet rather than how you normally would, which would be over USB if you're using a real device. Or Google's own SDK emulator already has all this set up to use ADB over the network. So I just have to uncapture my mouse and come back to my terminal. So I've just got like a terminal here. Let's see, there. I just need to grab the, get rid of my to-do list there. Bring up, so what I'm going to actually do is, maybe if I just show you all. So I'm just connecting up, hopefully to, just pop that over there so we can see them both. So now I can do command. Now, oh, unable to connect. Oh, sorry. Awful. Great. So now basically I'm connected through ADB like you normally would be to a device. I'm just talking to that emulator, and I can just send a broadcast intent and go into display. So this is my client that I'm working for, so you can see that their domain name. And actually, let me just just because I have a terrible memory, I can't. Not remember. series of actions that intent actions that I created myself a few months back. I just need to basically find them in my cheat sheet and copy and paste them into the terminal. See, basically what I did was I created, I need to go back, a listener within the Android framework now. Oh, bigger.
Yeah.
Can everyone see that? Yeah. Cool. So basically, I just chose a name, a namespace name for the action that I was going to send, and I created my own data extra that the extras that I talked about before, called extra system bar visible, and it's that easy means it's a Boolean because they're typed, so you can have strings, ints. So essentially, what that'll do is broadcast that intent, and then any app that's registered to receive those will be notified. And in this case, what it actually is system code that I've modified in this image that controls the visibility of the system bar. So actually, I'll make that a bit smaller. Oops. What's the magic key to make it smaller? Good.
Needs to be set to false.
Yeah.
Oh, of course, yes. I'm glad that was a test to make sure people don't fall asleep. Thank you. Yes, so there you go. So now that hides it. And funny story, we actually originally, because I'm not a system hacker by any means, I was originally just writing the app side of things, the application that displays the signage, does the control systems, reporting back and so forth. I sort of got into this because one of the things we asked the vendor to do was to make this modification for the device we were using, and they just modified the device just to never show the system bar, which wasn't very good when you actually needed to do any kind of debugging or to use the tablets for anything other than the signage that we were using. So I came up with a slightly better solution, which is actually just to send an intent and make this runtime configurable. So now our app can actually choose whether that bar is visible. And for instance, if you want to debug the device, or just you can this backdoor basically that brings the system bar back up, and you can just get into the device normally and actually get to various system settings and so forth without having to jump through hoops like trying to plug in a USB cable into a device that might be mounted inside a ceiling, and you can't get onto the network that it's on because it's conveniently firewalled. So being able to actually do this is quite handy. Is there any questions if I've got time? Yes?
How do you do over-the-air updates for running application?
Yes, we do.
Oh,
sorry, how?
Yeah.
So basically that's a bit of the code that I wrote. So essentially it's just another app that we've got installed. I've actually recently just made it actually part of the system build to make it easier to deal with. Because previously what I was doing was I was signing it with the system certificate, but I was building it separately just like any other app. but because it was built with the system certificate, it was signed with the system certificate that was on these images, it had the privileged access, but I had to use reflection to actually get a hold of those APIs, because the APIs aren't just documented and hidden and protected behind this security layer. They're also not exposed in the SDK, of course, so you can't compile against them. You have to use reflection to be able to even call the API. Is that articulate?
Oh, sorry, like just if the app's running though, how do you actually update it? Just
Oh, actually, I see, yep, sorry. Oh, that works rather well because Android takes care of it all for us. So what happens is, if you call this API, it's still using Android's internal app install process. So basically what will happen is Android will kill the app that you are upgrading, and then I just immediately restart it. And it's actually really fast, at least on the device we're using. There's maybe like a half a second or less flicker as the screen goes black, and then just the content comes back up again. So yeah, luckily the API takes care of it for you. I haven't had to hack any of that lower level stuff. Yes.
That's using framework changes, I assume.
Yes, correct. So you can't hide, because the system bar is now the only full devices which don't have hardware keys. The system bar is really well protected now. There used to be hacks when Honeycomb came out. There was actually again a hack that someone found that if you sent a particular message, not via intents, I think it was, but I'm trying to remember what the exact mechanism was, but you could actually hide the system bar. And of course that was a security hole. It's just that there must have been some kind of debugging feature that accidentally got shipped. So in Honeycomb you could do that, and
so other than changing the framework, you have no options. Like I've got an app that's part of it's for adults and part of it's for toddlers. So what you're trying to do is exactly a kiosk type situation. So I can lock out the back key and I can lock out the volume and other things, but getting hold of the rest of it, the only alternative is to the framework?
Yes, and that's one thing that I really wish Google would fix, that they would provide some way of doing that. Even iOS now, in the latest version of it, because this is something that people with iPads, including myself in my former job, have wanted to do for ages. You want to create a kiosk which is completely locked down, and hence what people do, or have done up until recently, was put cases around devices to stop people pressing the physical buttons. With Android, it's even worse now, because as of Ice Cream Sandwich, because they're virtual keys on the screen, you can't even do that. And unfortunately, there is no way. Like, I'm hoping maybe in the next version they'll copy, re-implement something similar to that iOS has now with their, I think they've called it an accessibility feature, where you can lock down the device through some.
Does that include the home key?
With iOS, I believe.
No. With Android,
yes.
Is there a way of getting at the home key? Because there is a definition for trapping the home key, but it apparently doesn't trap.
Oh yeah, so the home key is what I was showing before. Just register your app. Like if you just register your app as a home intent, you just need to ask the person to mark it as the default. Like when someone presses a home key and there's more than one home app registered, it gives you a list, but there's a little tick box there.
Yeah, I'd like to be able to turn that on and off inside the app. Now, it goes in the manifest. Is there a way of doing that? Because it's a pain if you're on the outside and not the toddler, but it comes up with a thing because you're just expecting it to go home.
I'm not sure if I've used your app or maybe one of your competitors, because I wanted exactly the same functionality for my young daughter, and yeah, it's a real nuisance. There is no way to do it because it has to be user-driven, like at least in the stock operating system. So I don't even know. Actually, there is one bug report in the Android bug tracker asking for the nav bar to be removable by people who actually just want it full screen, without even the grey out when they're watching movies. I think something like this is actually a more important use case. So I guess starring that might prompt them, but it's a bit of an opaque process what they decide to implement.
Just on that, Google themselves are saying wrap it in a case, and even if it's on screen. But then you got a problem with the size of the system. But yeah, they're still saying that. So
wow.
I mean, have you contributed to AOS?
I haven't, and the patch that does this is relatively small, very self-contained, and I'm planning to send it up, actually, to contribute it up to the Android 86 community, because a couple of my other tiny patches have been accepted within hours, because the guys who maintain it are really good. I haven't submitted it to ASP basically because I thought it would be a waste of time. I didn't think that they'd be open to that, but because the thing I should also mention, this is an original idea. If anyone's used CyanogenMod ROMs, they've had this functionality for a while where you could enable turning on and off the system bar. I think it's you get a choice to do it on the power menu, which makes perfect sense to me. So you can still hold down the power with the CyanogenMod ROMs. You can tick a setting so you get this functionality, and you can turn it on and off by basically there's then an extra setting in the power menu. So instead of just off airplane mode and so forth, there's another one saying toggle system bar on and off. So that would be a logical way to do it if they wanted to. It's very easy to tie that into here, and like I said, other people have done it before me. Maybe I should contribute and see what happens.
You should.
I don't think they would trust that developers with that.
Oh no, but you can still do it as no, yeah. Yeah, I don't think they'd accept the sending the intent part. No. But yeah, having some way that's still within the user, it's a fine line, because you don't want to expose this kind of functionality to Google Play Store apps, because that's going to end badly.
There's apps that turn off the system bar, so what is it, navbar at the top?
Yes.
Which people find extremely frustrating. You know, there's some readers that do it.
Yeah.
And it means that you're stuck in the app. You've got to leave it to, see a notification or something.
Or check your battery status.
Yeah,
yes. Yeah. Hello, Kindle. Yes.
Yeah.
The thing to bear in mind is that if Pi is actually based on SE Linux, it might actually totally change the permissions and control structure, and a lot of the things you're doing here might go out the window with the next version.
Possibly. I've been having a bit of a look at how, because I think a lot of that is aimed at the multi-user support that's appeared in 4.2. I'm not a huge expert on SE Linux, so I don't pretend to know particularly well, but I think it's more orientated that they're actually trying to bring in some of the common functionality from desktop OSs, like multi-user support, and that appears to be the strategy they're taking, because currently multi-user support in 4.2 it seems to be done as a kind of hack. Like, you can see that they've tried to implement it quickly, but it doesn't make sense in all the ways that they've done it.
It's difficult to know exactly what they're doing, but the thought was that if they wanted to get the corporate market and being able to lock the thing down to a corporate side of things would work quite well, and if they can pull in the SE Linux. So you're just saying that maybe that a lot of things you're doing here might change.
Yeah, and that's the thing. That a lot of the stuff I've had to do here, I should say, was done because we originally were on Gingerbread 2.3, and there was none of this hassle. The devices had physical buttons, which a hardware vendor was just going to remove. But as Linda said, like in 2.3, or you still can just remove the nav bar. That's no problem. So we were quite happy. We had full screen control without any issues. But then 4.0 came along, and the hardware vendor said, "This is what we're now supporting," and it turned out, oh, okay, now we have to deal with the system bar. So it doesn't help removing the hardware buttons. Yes?
Just stepping back a bit, just curious, how do you find, what's the reason you're using Android for kiosks? I mean, is it because you can find cheap tablets and sort of get them at a low price, or I mean, you could obviously get a cheap PC and sort of...
It's not so much a price motive, so much as support. Like the thing, like as I mentioned previously, for instance, with custom touchscreens, they're kind of like the bane of signage people's existence, or at least my existence, since I've been doing signage. And it's really hard to find decent support outside of Windows for these custom touch overlays. And the good thing with the ones we were dealing with is the vendors. It wasn't up to us, the vendors of the touch overlays who the hardware vendor was sourcing from provided Android driver that's provided Android support. Of course, the drivers were Linux kernel drivers, so you have to, that's why I talked about dealing with recompiling the kernel, because you have to then recompile the kernel to get them into the system image. But at least it was mainly hardware. The fact that hardware vendors seem to be willing now to treat Android as a fully top tier supported operating system alongside Windows. Because in the old days it was pretty much just Windows CE, and really Linux was like an afterthought. And even if there was support, like drivers usually out of date, didn't really work with half the variations of the hardware you got. So like in a few years back, I was actually working at the National Gallery of Victoria in the multimedia department and doing a lot of screens there for exhibitions and things, and we had a huge amount of problems even getting decent support for OS X with the touchscreen drivers, let alone, because we didn't want to, we had various issues using small Windows boxes. But yeah, it's mainly the hardware support from the vendors that they're willing, it's great that they're willing to basically say, this is supported, if it doesn't work, it's up to us to fix it.
Just curious with the size of screens and things you've got, is Android's X large still the largest, or is there something coming out for your kind of applications where you can have an enormous screen?
I haven't, to be honest, I haven't had to deal too much with the screen size definitions, because I should have also, one thing I didn't mention was the signage platform that I'm working on. It's web-based, so it's actually what the main app is essentially a full screen web view. So it's up to the web designers to deal with it. But actually, I don't know if I've got time. One little tidbit I can share is that up until recent versions of Android, and I think this comes back to your talk about memory usage of images, there's a hard-coded limit in the WebView/WebKit implementation of Android, where any uncompressed image over 2 meg gets compulsory subsampled, which meant the web designers would do these really nice full-screen images with lots of crisp text that was no longer crisp when we were displaying it on a similar size screen to that at 1920 by 1080. And it turned out that that limitation was, I actually finally found it via a helpful Stack Overflow comment in the WebKit saw Android platform-specific code, and it was just a comment there saying, this is to support devices with less than 256 meg or less of memory, and I've tested this on most websites and they look okay, e.g. abc.com, but might have to look into this in the future if people complain, or if there are issues, something like that. So there you go, like even the Google Android engineers are human and put in these arbitrary limits, and hey, 2 meg must have sounded good, but as you probably know, 2 meg uncompressed images.
You can't make text.
No. And I got to look, because I'm not a graphics guy, I got to learn what subsampling was and what it did to an image with lots of large text.
Well, there's better reasons not to put text in images on websites.
Yeah. Well, that's. I'm not the web designer. I'm colorblind. Like they don't let me design anything. Yes.
Are you planning to do anything more with the fact that you've got an Android device sitting there and you've got lots of people with smartphones walking around, or is it just trying to replace the Windows side of things? And as a kind of aside, where the hell do you find decent large screen digitizers that don't cost the earth?
I'm not sure. I don't deal too much with the hardware side of things, except that I get given devices to test with. And like the largest one I've dealt with so far is a 42-inch, so a bit smaller than this. And yeah, it was pretty sure it's a multi-touch digitizer and done in like I think a special glass to make it fairly robust to use in public spaces. But I don't know how much they cost, but I don't think they're well priced.
No.
So sorry, I don't.
They cost more than the monitor.
Yeah, and I think what you might find is that it's actually hard to find decent ones, especially ones you can put in public spaces. I know that was either Acme or Fed Square, had a number of outdoor screens, like in Fed Square. And I don't think any of them ever worked longer than about 2 days. And apparently the glass was like this thick, and the people still managed to break and crack the LCD behind it. So anything that goes into a public space really needs to be ruggedized. I guess I've run out of time. Thank you very much.
Alright, so recently these are some of the guys that will be attending here tonight that have just recently released the apps on the Play Store. So let's go back to this one. So James, is James here? Yeah. So you're at Monash University. Is that just you or a team? Just you? And obviously it's about Monash.
Yes.
Did you want to say something about it or?
Sort of nothing in particular. I don't really know what to say about it.
Okay. And the NRL live app, he's not here. Alex with Check Cosmetic, not here. Lyndon, I know he's here. Tell us about Heart Rate.
So Heart Fan. It's for Melbourne Heart.
Yep.
You know, if you want to follow the game, you don't have to be a member, but it's a big part of it is member acquisition for the team, and they're the underdogs. So don't go Victory, go the underdogs. What's that? Oh, I don't know. I've been away for a while. I'm also not the mega soccer fan. So Alex Yanni got me into it. He made the iOS app. And it was a bit, I got to basically get licensed to Thrill on it, which meant I got to make executive decisions to the iOS design, to port it to Android to make it really nice. So it's doing some kind of cool stuff. It's doing Google Maps, like it dropped, 4.2 dropped while I was making it, and I sort of backtracked and integrated that and nested fragments. Google Maps API version 2 dropped, you know, 4 days after, or just when I finished integrating my own old version 1 fragment fix, and so I dropped that and integrated it. And it's doing some interesting stuff with forms as well.
Yeah, just pertinent to the Monash University app. Exactly the same thing happened. I was working on the maps, which is pretty much like most of the application, and then the new API came out. I was really struggling with the previous API, but the new Maps API is like actually a lot better than the iPhone API, and it was a lot of fun to use. So
yeah. That was all the truth.
I didn't say it's free though, so.
It's free.
Yeah.
Lewis?
Would you like me?
Hanson. Yeah, that's for Hanson Concrete. Support an iPhone app. Most of my work is supporting iPhone apps. I've got normally like about 1% ability to change the design to suit the device. The rest of it's got to look just like the iPhone. So yeah, they just give me like, here's all the artwork, make it. But yeah, it's to browse their precast things like empty septic tanks, water tanks, whatever. Find your local stock lists, all that sort of bizarre.
Yeah, it's Paul here. Oh, Richard. I'll put these guys down. All right, just a quick plug for some of the other meetups going on around Melbourne at the moment. The Google Developer Group, Melbourne. They're doing a lot of cool stuff. I figured it's very similar interests to us. And Melbourne JVM. I think we've actually got the organiser here tonight, so actually held me down and made me put that in. And a big thanks to our sponsors, obviously for Shine Tech tonight for sponsoring food, drinks and venue, and just continued support from Open Hub and J-Tribe, who are our other venue and drinks and food. So thanks everyone for coming down, and enjoy the beer. The pizza just got here, so do you again.